Hello everyone, welcome to our channel Mathematics Parshala. This is a problem of CSIR NET December 2023 Mathematical Sciences. This is a problem of linear algebra part C. The question ID is 704078. So to solve this question, first we read the question. Consider the quadratic form Q xyz is given by this. Then which of the following statements are true? There exists a non-zero u belongs to Q3 such that QU0. There exists a non-zero u belongs to R3 such that QU0. There exists a non-zero u belongs to C3 such that QU0. And option 4 is that the real symmetric 3 by 3 matrix A which satisfies this is invertible. So first we have to find the associated symmetric matrix corresponding to this quadratic form. That is, we get A equal to just there is a system to write this matrix. This is 1 1 1 corresponding to the coefficient of x square y square z square, and this is 1 2 position, that is xy, so it is divided, 1 is divided by this half half, and then this is 1 3 position, that is for xz, so it is also 1, so 1 is divided by 2, so it is half half, and similarly for the yz position it is half half. So this is the symmetric matrix associated with the given quadratic form Q. So if we apply congruence operation to this matrix, then we find that matrix which will be congruent to the given matrix and simplest form. So if we apply congruence operation, we have to apply R2 plus minus half R1, and also for the third row R3 plus minus half R1, and just after simple calculation we get this matrix 1 half half. First row is unchanged. In the second row we will have 0 3 by 4 half. For the third row we will have 0 half 3 by 4. Then the similar operation for column, so it will be C2 plus minus half C1 and C3 plus minus half C1, similar as the row operation. So then we will have first column unchanged 1 0 0. This is 0 3 by 4 half, 0 half 3 by 4. Then again we have to apply to make this element 1 3 by 4. What we can do, we can do 2 by root 3 multiply 2 by root 3 R2, and also then again 2 by root 3 C2, then it will be 4 by 3. Yes, so it will be 1 0 0. This is 0 1, and for this element it will be 2 root 3, so it will be 1 by root 3 probably, and for the second column it will be 0. This is 1 by root 3, and this is root 3 in numerator and 2 in the denominator probabilities. Okay, then again we have to apply that congruence operation. We have to apply this R3 plus minus 1 by root 3 R2. So we will get, this is unchanged 1 0 0. This is also unchanged 0 1 1 by root 3, and this is 0. This is 0, and this will be root 3 by 2 minus 1 by root 3 into 1 by root 3. So this will be root 3 by 2 minus 1 by 3, whatever. This is root 3 by 2 minus 1 by 3. Then the same operation for the column. It will be C3 plus minus 1 by root 3 C2, and then it will be 1 0 0. Second column is unchanged, 0 1 0. For the third column, this is 0 0, and this element will be what? This will be also same, root 3 by 2 minus 1 by root 3. Now the question is root 3 by 2 minus 1 by 3 is positive or negative? So clearly if we square both, so it will be 3 by 4 and it will be 1 by 9. So this will be greater than this. So we have root 3 by 2 greater than 1 by 3. So we have root 3 by 2 minus 1 by 3 greater than 0. So also we can make it 1 by some multiplication on third row and also third column. So ultimately the congruent form, that is will be finally 1 1 1 and the other positions are 0. So this matrix is the congruent to the that matrix A. So now look at the options, and also for this matrix the quadratic form is becomes xt, that that form becomes x square plus y square plus z square. So that q, if we write it q1, so q1 is congruent to q1 xyz is this. So clearly this is positive definite from this form. So it is greater than 0 for all such u belongs to R3 not equal to 0. So for this option 1, it says that there exists a non-zero u belongs to Q3 such that Q equal to 0. So this is not true, because all such u non-zero u belongs to Q3 also as well as R3, Q will be greater than 0. So option 1 is not the correct option, and option 2 says that such u belongs to R3 such that Q 0. Also this is not the correct option. Now look at option 3. There exists non-zero u belongs to C3 such that Q 0. Yes, such u in C3 can be found if we take simply u equal to just omega 1 0 belongs to C3, which is non-zero u. Then see here our Q1 u will be, that will be our omega square plus 1 uh, okay, omega square plus 1 plus, so okay, we can write this root omega, then it will be plus omega, and we know that 1 plus omega square equal to 0. So such u belongs to C3, non-zero u can be found such that q equal to 0. And also this is q for such u can be found in C3, because all the polynomials will split in C. So such u can be found. So option 3 is the correct option. And look at option 4. The real symmetric matrix A which satisfies this is invertible. So this is that matrix A, and that is congruent to this matrix. that is congruent to this 1 1 1 in diagonal position. So clearly the date of this matrix will be 1, which is not equal to 0. So this matrix is invertible, and hence that matrix A, the given matrix A, is also invertible. So here option 3 and option 4 are the correct options, and also for this look at option 3 again, that we have found some u belongs to C3 such that q1 u0. So from this structure, as q is as we can find this u in from the given form of q without using this congruent q1 of q, because just see simply just simply here our q is given like this: q x y z is x square plus xy plus uh, y square plus xz plus yz plus z square. So simply, if we divide this by z square first, then we have z square into, just this is x by z whole square. Okay, first we just take z equal to 0 simply. Z equal to 0 simply, then when we choose that u equal to some xy 0 from C3, then we just choose z coordinate is 0 simply. So our for that u, it will become uu will become simply x square plus xy plus y square plus xz0 yz0 z square 0. Okay, fine. Now just see here, just divide it by y square, then we will have x by y whole square plus x by y plus 1. Now we just take x by y equal to omega simply. So x equal to simply y omega. So now just take y equal to 1 simply, then our x will be omega and our z is 0, we have taken already. So our u becomes x is omega, y is 1 and z is 0. Yes. So for this q is simply becomes omega square plus 1 into omega plus y square, that is 1, plus all the elements are 0. So this is clearly 0. So just take u, this element which is not equal to 0 from C3, and just see that q is equal to 0. So for the third option, we don't need to look at the congruent form of q. Just we can find some u belongs to C3 which is not equal to 0 such that q is equal to 0. Just taking z coordinate is 0, we have simplified that q, and then we can choose xy what we need. So in this way, we can find some u belongs to C3 not equal to 0 such that q equal to 0. So option 3 is the correct in this way. So don't need to follow this. We have proved already that our option 3 is the correct option, and option 4 also correct option we have proved. So here option 3 and option 4 are the correct options, and option 1 and 2 are not the correct options. This is the solution of this problem.